In this example, figure 3 shows the design of a structure used to support a roof. The structure consists of 4 wooden beams, BC and AB. Given AB is 6.5 meters, BC equal BD and it's equal to 4.7. So let's write this down so we have a little bit clearer. So for AB is 6.5, BC is 4.7, and BD is also 4.7, and we have BAC is 35 degrees. So for part A, we need to find to one decimal place the size of ACB. So this is so we need to find ACB. So this is the angle that we are looking for. So in this scenario, we can use so we can say for part A, using sine rule, we can see that we have the angle of so this is the angle of theta. So we can say sine theta over 6.5 equal, we have sine of 35 degrees over 4.7. So now to simplify this, we would have sine theta to equal 6.5 multiplied by sine of 35 degrees over 4.7, and then we would have theta equal sine inverse of 6.5 sine 35 degrees over 4.7. That would give us 52.5 degrees. And since it is obtuse, then we would have theta will equal 180, take away 52.5, that would give us 127.5 degrees. So this is how we find the angles for part A, which is the angle of ABC. Now for part B, we need to find the nearest meter, the total length of wood required to make this structure. So and we found the angle of ABC, so B, angle ABC, it would be 180, represented by 180, where you would have 35 plus 127. So you add the two angles and take away from 180. So that would give us 17.5, which is the angle here, which is the ABC. And now we can use this angle to, and we can use the sine rule. We can find the total length of wood required. So we would have in this scenario sine of 17.5, which would be the angle here, and we have we're trying to find AC, which is here, and we also have the length of sine of 35. So we have the second angle 35 over 4.7. So now for us to find x, that will be represented in the form of sine inverse. In this scenario, we would have 4.7 sine 17.5 over sine 35, which will give us in this scenario 2.46 meters, which is representing length of AC. Now, so we found AC to be in this scenario to be 2.46 meters. Now we need to find CD. So to find length, again using sine rule, we would have sine of 52.5 over 4.7. That would be equivalent to sine of 75 over x, and that will give us, when we have the x's multiplied, so that will give us x to the 4.7 sine of 75 over sine of 52.5, which will give us, in this scenario, 5.72 meters, and this will be the answer for in the scenario CD. Now, what we would have in this scenario, we would have the length of 2.46, and we also have the length of 5.72. So that's we would have AC. So we would have AC plus AD plus AB plus DB plus AB plus AC, and so the total length that we would have. So say total, so that will be 2.46 plus CD is the one we found, which is 5.72 plus DB, which is 4.7 plus 4.7, which will equal 24 meters, which is the nearest total length. And this will be our answer for part B in terms of having all the total lengths, and here we just need to highlight that this part is CD length.